This is Kelly Shannon coming to you from Belgium. Thank you very much for allowing me to take a bit of your time to talk to you about the impact of global warming and climate change in Southeast Asia, with an emphasis on flood and rising sea levels. So I think it's important first to spend a little bit of time to talk about some techniques and some technical terms. We talk about flooding often in a very generic way, but in fact, we have 5 different types of flooding, and we really need to know which kind of flooding we're talking about when we use the word. So the first is river flooding. River flooding is coming about naturally, because when we have water going into a river, it gets full of its floodplain and it overflows. But in today's contemporary world, it's being exacerbated. The reason being is that we've tended to engineer our rivers. We've straightened them. In some cases, we've even buried them. And we've shrunk the floodplain, so the natural space that the river would be able to have more water. So what we need to do is we need to make more space to have more water and often revive or revitalize our rivers. A second type of flooding is one we can call, or that is called, fluvial flooding, more commonly known as surface flooding. And of course, this is what we see in many of our settlements where we have lost the natural permeability of the soil because we've covered it with asphalt, we've covered it with hardened surfaces, so we get a lot of water pooling or collecting on the surface of our territories. We also have an increase in what we call flash flooding. So flash flooding is where we have problems because of the speed of water and the overflow. And of course, this comes when we have storms, when we have monsoons, often leading to things also like landslides. Coastal flooding is also an issue that I will talk about quite a bit more. And it has a lot to do with sea level rise itself, the sinking of the land or the subsidence, and also the rise of sea level itself. And finally, we also have another type of flooding that is called groundwater flooding. So it's where we start to get water that comes from the underground and reveals itself on the surface or in basements. And this has a lot to do with the fact that we're changing also the underground consistency of the soils, and that when we have too much water and it has no place to go, it goes in the shallow water lenses underground and then begins to seep or percolate back to the surface. So another thing to understand in terms of technicalities is that there are many different causes that make the sea level itself rising. The one that is talked about and is very alarming to scientists is that the world's glaciers are, of course, with warming temperatures, are melting more rapidly and then flowing back into the ocean, giving more water to the ocean itself. The ocean water also is gaining more space simply as the water gets warmer and as water molecules expand. We also have a change in currents and circulation that comes from this sea level, or that makes the sea level changing. When we talk about sea level rise, we also have to understand we're given often numbers, and I will show you some numbers, but these are general because they're very, very localized according to the different geographies and forces on it. As I already mentioned, we also have subsidence. So we have, which means the land is sinking. So as the land sinks, the water surface naturally expands. And of course, a lot of our taking of groundwater, which of course then causes the subsidence, is about our drive to get ever more fresh water, which we often extract from the underground with pumps. So here we're seeing a few interesting diagrams that show, on the one hand, we have changes in the sea level rising for the reasons I just explained to you. Of course, that becomes worse. We get more water inland when we have storms. But at the same time, we often have our cities and settlements that are going closer and closer to this kind of interface of the land-water edge. So we say have troubles coming from both sides, and where we need for ever more space, a bigger floodplain for the ocean's waters. To explain a little bit, also terminology that's often spoken about, especially more and more in the news as we get more floods, are the terms spring tide, and even sometimes we call it king tide. So when the spring tide is when the distance of the low tide and the high tide are the most extreme, the largest, and it's when the new moon and the full moon align with the Earth and the orbit of the sun. The orbit of the Earth and with the sun. And conversely, we have a smaller difference of the high tide and the low tide. So the tides that are least dangerous are what we call the neap tide, and that's in the first and the third quarter of the moon's cycle. And again, two diagrams that show a very interesting phenomenon that we must understand. So this interface of land and water, it's of course a very rich interface, but it's also a very fragile interface. We understand that as we have waters arising, and the intensity of storms are also becoming more severe, the intensity of waves battering the shore, we're having, in many instances around the world, a retreat. So the shoreline is becoming further back. We're losing land. We're having a significant amount of erosion. And this happens on land. This happens to our topography. But also below water is what we call bathymetry. And also we have to understand that that is also changing. The diagram below, diagram B, is also showing the similar changes in the topography and the bathymetry, the topography under the water, when it's, say, not as smooth. So again, we're always having a retreat, but sometimes we also might get more sedimentation as opposed to the top one where it's only erosion. Here is a diagram coming from the Intergovernmental Panel on Climate Change, a report that is made by a collaborating group of scientists throughout the world under the auspices of the United Nations. I've pulled out the one here about the predictions for sea level rise. Again, global sea level rise, global average sea level rise. So it will be different spot by spot and even within nations. But what it shows is, without a doubt, we are having sea level rise. And then the colors that you need to pay attention to a little bit and understand, this RCP, which means respective concentration pathway. The orange one, the dark orange, is basically business as usual. If we do nothing, this is what we'll get. The dark purple one is if we do all the ways to mitigate and to adapt, this is what we can get. Of course, humanity will probably not be in either extreme, but somewhere in between the light purple and the light orange. But what's really astonishing to see is even if we now start to act, we can only dampen the effects, but not anymore stop them or fully alleviate them. We do know, of course, Southeast Asia is the fastest growth in CO2 emissions. It comes from the rise of economies, the need of more industry, the use of more fossil fuels, But of course, this is something that means how this problem becomes an opportunity for us to think in radically new ways, how to grow without destroying more of the world's environment. Here is a quite shocking, I think, diagram published by National Geographic. It shows in the lightest blue, so the interface between the ocean and terrestrial land, the areas that will be severely flooded or even completely inundated. And it's a quite shocking amount of territory, and where, of course, there's huge populations that are living. So when we look to the area of, in this case, the greater Mekong subregion, I will be focusing some examples in the Mekong Delta region. But of course, we always have to understand any site we work on, whether it's an individual site for a healthcare facility, it's embedded in a larger system of ecologies, a larger system of social and ecological systems. Here, I'm going to be talking about the Mekong River Basin. We know that it's an area that is highly populated, but also highly threatened. Here in the diagram in the left, you're seeing in the Mekong subregion, you're seeing all of the deltas, all of the dams that are being proposed or already built. And in the Mekong Delta Basin, the diagram on the right, you begin to see how extensive just along one river, one 5,000 kilometer river, how many dams are being built. So the area I will now focus on is this watery area of the Mekong Delta. The Mekong Delta does not know national boundaries, of course. It spans between Vietnam and Cambodia. What you see in the left is the Great Tunnel Sap Lake, a wonderful lake that has a phenomenon of reversing its course during the monsoon period. It's a lake intimately tied to the whole rhythms of the mighty river. So here again, you see the power of that system coming to the East Sea and the Gulf of Thailand. So here we begin to see also the vegetation. I would point your attention to the dark purple along the coast. These are the mangroves. Mangroves are wonderful plants. Unfortunately, humankind has been destroying them rather than taking care of them over the past decades. But they're great, say, natural resistors to coastal flooding. So we have to think about how to bring these back. Deltas in general are great population centers. They offer a great deal of resources, but we know they're also some of the more vulnerable and more threatened areas. Similar in Thailand, the great deltas are where the great population centers have historically and are today. Important to understand is that every territory is full of a great many different ethnic groups that are still coexisting, sometimes more or less peacefully. But what's interesting is these different ethnicities over many millennium have developed different traditional ecological knowledge, different ways of respecting, taking care of the territory. And the hypothesis we have in our work, also with the Vietnamese government, is that many of these other knowledges can also be understood and used for the contemporary world. So a few images also again coming from National Geographic about this Mekong Delta, the Mekong River. Again, the Tunnel Sap Lake, it's running dry. Why? Because of many dams upstream. It's taking with it many of its wet forest and many of the fish where much of the population subsides, has subsistence economies and daily protein. Also, we know that throughout Southeast Asia, where we have a lot of wet, watery lands, there's a massive amount of sand excavation, sand mining, in order to get sand to build ground for our housing, for our buildings, for our healthcare centers. So we have to be very aware that where we don't have natural land, but more wet lands, we're often changing the natural system and creating with it many new problems. So rivers themselves are also changing their flows and the amounts of water, again, partially because of the upstream water politics and dam building that is going on. And here we see also some of the consequences of this. The dams have lowered water levels, but then also when they're opened, they maybe have water coming at a velocity not usually experienced. So a focus on the Mekong Delta, and first on the Vietnamese part of it, where in our research center in our university, we've been doing some work. Here, what we tend to do is we try to understand how different policies at the national level, and regional level respond to global warming, respond to climate change, and then what are different adaptation strategies. So here I've put in orange boxes the two that are maybe interesting for you and your workshop. So understanding when we need to protect and adapt our water resource management, we have to continue to improve drainage. We have to limit where we allow populations to live and not live, to build and not build, to use water very, very efficiently, and then to understand it's part of a large ecological system. And most importantly is possibly the notion of living with water, living with floods. Why do we have to excavate stand to make land when we can also change the way we live? We can live on stilts. We can live in floating houses. We don't have to live on terra firma. We don't have to live on earth. We can live on the water and with the water. In terms of healthcare, some of those similar ideas can come through. And of course, many of the issues that you're no doubt covering in your workshop deal with many of these adaptation measures that are pointed out here. I won't go into detail, but you will have access to this presentation. So again, if we start looking at the coasts in particular and general impacts of coastal areas, we of course have, as we know, sea level rising. And of course, that's influencing very much coastal infrastructure and coastal architecture and urbanism. And then the whole series of nested troubles that come with floods and droughts, changes in our rain patterns, and of course, the increased frequency of typhoons. So an image that probably is familiar to many of you, we know of the territory much of Southeast Asia being incredibly fertile, incredibly productive. Of course, we understand this is also threatened by changes brought by global warming. But for me, what's also very interesting to understand in this great water regimes that allows rice civilizations to happen, the region has always lived with water, welcomed water, farmers welcome the water. It's only in the past decades that we've started to very much fight water, to build dikes, to build dams, to harness the water, but not to really say to live in harmony with the water, playing with the water. So I think that's something that we can begin to understand, and how, as you see here, soft, small manipulations of topography can allow us to be very productive and also to live well with water systems. I'm now going to go into a little bit of a project to give you some ideas potentially at the scale of a territory. This is a map that was published by the New York Times that the Vietnamese government is not very happy to share with its population because it shows a scary predicted future of too much water. But the question for us as architects and urbanists is how can we actually not be, say, scared by such a projection, but to begin to understand how we can adapt the way we build, how we can adapt the way we live, how we can adapt potentially where and how we build also healthcare centers. When we start projects, we very much spend a lot of time trying to very precisely map and understand the territory as it is. Here we look at soils, we look at topography of both the water and of the land. And what's of course very interesting, you see in a map here, is the worst flood depth is not, as you would think intuitively, along the coast, but it's actually further back in the delta where the land is lower. So we always have to kind of check intuitions with actually the kind of mapping on the ground to understand what we are really dealing with. Here already starts to be a propositional framework. It's about the infrastructure and the settlement. And what I would draw your attention to here are the dotted lines, the dotted yellow lines in the very dark blue area. Again, the dark blue area near the border of Cambodia is the area that will be flooded more. It's lower land. So we discussed with the Vietnamese government that perhaps they should rethink some of the loans they had from the World Bank, the Asian Development Bank, to not build big, new, heavy infrastructure there, since it will inevitably be flooded. So the reason I show you this is it's about understanding where to build, where to not build. And even when you're thinking at the scale, not of a huge territory, as you see here, but even of a single healthcare center, where to situate it becomes something very important. Also interesting to think about is the use of vegetation. Here at the scale, again, of a delta, not at a healthcare center, but the scale of a delta, where to begin to bring in new vegetation. Here is bringing in a system of mangroves, huge amount of mangroves that can act as a resistor to the coast, to the sea level rise, to kind of dampening the effect of waves, as a front row of protection, and a second row of having mangroves that are also part of a productive landscape, part of aquaculture that can exist in a new sustainable way that is not depleting the mangrove, but coexisting with. And finally, this is the plan that we presented to the government. And the big thing we changed mindset here is to accentuate this delta as an agricultural wonderland. So not to say development equals the need of massive new high-tech, software-based technology industries, but actually the industry of agriculture, the industry of feeding people, of taking advantage of your environment can be very interesting. We designed for them in the area you're seeing in blue, a way to catch monsoon waters and to then release them downstream, and to basically have the water system, the flood system, living with floods, and an agricultural vegetal system being the frame for urbanization and not the other way around. So it wasn't building cities and then greening them, but it was using the frame of the landscape to be the frame of where to build and where to not build. We then developed some different typologies. So this is a typology of the monsoon reservoir. So collecting all this wonderful monsoon rain upstream, keeping it in huge new lakes that also can have new productive economies, and housing and settlements around it that are on stilts. In the more land that is not as affected by flooding, but still has seasonal flooding, to build here kind of high dry islands that you see in white in the drawing on the left, where you have high density population, and the area around is a productive landscape that can flood, that can get inundated, but without threatening the population. You could do this at the scale, I would argue, of a healthcare center, having it high, dry, and safe, almost a place of refuge when larger emergencies, and then otherwise having it surrounded by the productive landscapes. At the coast, we worked with creating, again, this monsoon, to mangrove systems, massively replanting mangroves, creating clearings in mangroves where you could have houses that would float. All of the housing that we proposed and buildings would all have solar energy, would all be using local materials, and also, as you see here, having renewable energy coming from the coastal winds. And a very important component for us that we did at the scale of a territory that can also be done at the scale of individual buildings is to rethink water management, rethink how to hold upstream or even locally rainwater, how to use things like gravel dry wells instead of, as you see on the drawing above, massive pumping. So this massive pumping we do with diesel pumps is not sustainable. It forces we take water out of the aquifer underground, which depletes these, and it also causes subsidence. So it causes the sinking of the ground. This is the plan we ended up developing for the government. As you see, the red, so the engineering systems of cities and of roads is of course there, but the very important frame upon which they are decided where to be, how to be, is the green and the blue system, the water system, and the vegetal productive landscape system. And then I would just like to end at a completely different scale. This is made also in the same delta, in the area of the border of Cambodia and Vietnam, by Nishizawa, a Japanese architect living in Vietnam. And it's a house made with local materials, fitting into an already built neighborhood. And what is so interesting, I think, and a lesson to learn from this house is, one, the use of local materials, the way it fits into its environment without being seemingly new, but the very innovative and new way it deals with, one, the materials, but also natural ventilation, the need, getting rid of the need and the reliance on things like air conditioners. So here we see the house in red in its larger context, and again here in a detail where we understand the kind of coexistence of a productive landscape, both from fishing and from farming, but also of a sacred landscape with tombs between the most of the housing and the rice fields, and the way the house slits into its environment without overwhelming it. Here you see a section. It's a house, again, raised on stilts. It can deal with flooding, and it can also deal with natural ventilation, and working very well with getting different air currents, collecting rainwater for local use, also through the way its gutter system is set up. And then its materiality, using local materials, having quite a lot of green. Also, when we think about healthcare centers, green as a healing element is, I think, something very, very important. So I end with these, I think, quite amazing slides of how we understand these amazing images of how local materials and understanding of a local architecture can be updated to become part of the new modern landscape. So I hope this will be of some help for your workshop. And please don't hesitate to look also at two websites. The first one is for our International Center of Urbanism in Leuven. And the second one is a series where you can download a series of publications also about water urbanism, etc. A whole series of books on academia.edu that are downloadable and available for your use. Thank you very much. And I wish you well for your summer school.